Okay, this video is on exponential functions in class practice, and it's 4.2 number 2, where we're talking about how to take basic word problems and find linear and exponential formulas for them. So this one has the number of asthma sufferers in the world was about 84 million in 1990 and 130 million in 2001. Let n represent the number of asthma sufferers in millions worldwide t years after 1990. Well, when I see this t years after 1990, I know that 1990, I'm going to let time be 0. Then I look at it and say, all right, if time is 0, if there's 84 million in 1990, this is going to be my initial value of whatever I do, okay? Or my y-intercept, if you will. And then they said there's 130 million in 2001. So let's set up some points here to see what we have. Our first one is time is 1990 is 0, and I know there's 84 million. Then I want you to label a crap out of it. So here's my years since 1990, and this is millions of asthma sufferers. Okay. Our next point is going to be 130 million in 2001. So 2001 is 11 years after 1990, and there was 130 million. Okay. So now that I have these two data points, I can go through and find the formula. Well, the first thing, if I do linear, I know linear is y equals ab to the x. And now I'm going to put in my initial value, in this case it's a. I know, oh, excuse me, it's not linear, that's exponential. Let's start that again. So y equals b plus mx, I apologize. So I know that the 84 is going to be my initial value here at b. So I'm going to say y equals 84 plus mx. Now, the only thing I have to have now is my slope. And I do know that the slope is going to be positive because this is growing. So I'm going to do my slope is my change in my y's over my changes in my x's. And I'm going to go bottom up. So I have 130 minus 84 all over 11 minus 0. And when I do that, I get my slope to be 4.182. All right. I'm not using a fraction this time because I want to know per year what the slope is. And I want you to remember that this is in millions of people. This stands for per, and this stands for year because I did my y's over my x's. So the unit of this is millions of people per year. I just want you to keep practicing that so that you would know your units, and it's really easy to do if you label everything. So now they said to use n's and t's, so I'm going to. So the n is the number asthma sufferers is going to be 84 million plus 4.182 per year, million people per year. So there right here is my linear function. Now they say, what is the slope and what does it tell you? Well, it tells me that it's increasing 4.182 million asthma sufferers per year. Now let's look at b, and this is what I tried to do before. They want you to do an exponential function, so I'm going to do y equals ab to the x. I go back to my initial data points, and I still have my initial value. So in my equation, it's y equals 84 b to the x. Now I look at this and say, well, I've got to find my b. Well, you don't need to do the ratio part. All you need to do now is plug in your other data point, which if we look here at the top, is going to be 11,130. So I put the 130 here equals 84 b to the 11th. And then I say, okay, b to the 11th is going to be 130 over 84. And then I don't care about b to the 11th. I want b to the 1st. So I'm going to raise each side to the 1/11th using my power to the power. So now I have b to the 1st. When I do that, I get b to come out to be 1.0405. Now, I feel really good about that because I knew that my b had to be over 1 because it was growing. So this formula is 84, 1.0405 to the t. Now, this asks, what is the growth factor? Well, the growth factor is 1.0405, but really, remember, this is increasing 4.05% per year. So you subtract the 1 and move your decimal place. So this is growing per year 4.05%. Okay? And what does this tell you about asthma sufferers? Well, it continues to go up, and that is true. It's a true story. Okay? Now they want to know how many asthma sufferers are predicted worldwide in the year 2010. Well, the first thing I want you to do on this is to actually take the 2010, subtract the 1990, even though you might think this is crazy. I have it 90, not 99, because I've had a lot of people miss this because they do it quickly in their head. So now I know I'm talking 20 years later from my initial formula. So I'm going to do n equals 84.4.182 times 20. So there's my linear. So that predicts to have 167.64 million. That's a beautiful M, isn't it? Million asthma sufferers. Okay, that's what's predicted in 2010. When I do the exponential one, I'm going to have 84 times 1.0405 raised to the 20th. And when I put that in my calculator, that's a 20, guys. N equals 185.83 million asthma sufferers. So this one shows there's more because exponential functions grow faster. All right? So that's that one. Now, the next one is kind of interesting because of the way it's worded. So I want you to pay attention because this is something we'll talk about in class. It says a 2002 Lexus cost $61,055 and depreciates, which means it goes down in value a total of 46% during the first 7 years. So the first thing I want to do is see if I can make some data points here. And the first one I see is when time is 0 because they didn't really tell us anything else. So I'm going to have my point to be 0, 61,055. So this is time in years. I label the crap out of it. And this is money. Okay. Now, the second data point they said is 7 years later. Okay. That's fine. But then they said it depreciates, which means the value goes down a total 46%. So if 46% went away, if I take 100% of the value, take away the 46% that went away, you're going to have 54% of the value left. So I actually take that 61,055 and I'm going to multiply it by 0.54 because that will tell you how much the value is left. When I do that, I get 32,970. And that's pretty good actually for a vehicle to have only 54% of its value left. Usually it's a lot lower. So they said assume the depreciation is exponential. So here's my two data points. I'm going to do y equals ab to the x. And now I know the a is going to be the 61,055 because that was my initial value. And I have to find b to the x. I don't know what b is. So now I can just plug in one of the points, and the other point is 32,950. So I do 970. So 32,970, I'll say that again, equals 61,055 times B, all right, because I don't know what B is, and we're going to raise it to the seventh, okay? So I'm going to divide, so I have 32,970 divided by 32,000. I'm saying that wrong. I want 32, divided by the 61,000, sorry. Yeah, I was saying it wrong. Divided by the 61,000, because I'm going to divide by this, 055 is going to equal b to the seventh. And then I'm going to raise both sides to the 1/7. This is the easier way to do it if they give you the initial value. So I find my b to be actually 0.9157. I want you to go at least 4 decimal places, so I'm going to use Christmas colors here. The value equation, if this depreciation was exponential, is my initial value of 61,055, and it's 0.9157 to the t. So that is my exponential equation. Now, when I ask you to describe this, this is where people kind of make the mistake. They are okay saying that it's 61,055, but then they're saying, well, how much did it decrease? You have to take that b and subtract it from 1. And when I do that, I get 0.0843. That means 43, not 7, sorry, 43. So that means, and if I move my decimal place over, that it decreased 8.43% per year. It decreased. You always, if your b is between 0 and 1, you always have to subtract and do that. Okay? Now let's say our depreciation's linear. So I say y equals b plus mx. The nice thing, I go back to my original data points, it's still 61,000. So this makes it really nice for the math, but I'm going to tell you, it isn't always like that. Now I have to do my slope, and my slope is going to be my change in my y. So I'm going to do the 61,055 minus 32,970 divided by, okay, so I got to do top down. I've got to do top down, 0 minus 7. And when I do, I get a negative 4012. So that's basically, if we were looking at the units, again, this is dollars, okay? This stands for per, and that's years. So that's how much it goes down, is $4,012 per year. That's my unit. Again, it's nice to know that's what it is, all right? So now when I come up with my formula, I'll use Christmas colors. The value of this one is linear 61,055 minus 4012t. Okay, so this one said the value started at 61,055 and it's dropping or depreciating $4,012 per year. Now, this last part says, if this was your car, so here I have these two green formulas, and you were trading it after 4 years, which depreciation model would you pick or prefer, exponential or linear, and why? If I ask you something like that, I want you to actually take the formulas and plug the 4 in. So we're going to do the exponential one, 61,055.9157 to the fourth. When I do that, I get the value to be 42,927. So that's the value of that car after 4 years. Now the linear one is 61,055 minus 4012 times 4. So the value here is going to be $45,007. And in this case, linear wins, because if it was my vehicle, that's what I would want to trade. And remember, it only works here because I said 4 years. If it was 6 years or 7 years, it might change. So that is this practice on word problems for linear and exponential functions. And that's the end of this video.